Good morning, everybody. Thanks so much for being with us here today, and hopefully you guys all fared okay with the rain we got yesterday. I know across the three counties it was pretty intense in some places, but glad to see it's a beautiful day this morning and that we're all able to hop on to this call. We've got Builder's Perspective, heat pump wa water heaters today. I'm Chloe from the Tri-County Regional Energy Network, and we've got Mike Horgan and Jennifer Rennick with us today for today's training. We're also recording today's training, so you'll get a copy of the recording as well as the slides a few days after this webinar wraps up. Just before we begin, a few quick reminders. If you're here to receive your AIA or ZNCD learning units, make sure you're attending at least 80% of the training. We do verify attendance. And you also have to make sure that your name is appearing associated with your account somehow. So if you're calling in, make sure you message us your name just so that we can confirm your attendance. We're going to be saving questions till the very end today. We've got about a half hour saved at the end of the presentation just for questions. So we're going to hold all questions until then. Um, and we're also not allowing AI note takers unless you've got like a disability or something that you pre-approve with us, just to keep things simplified in the chat for everyone. If you're new with us today, we're the Tri-County Regional Energy Network. We're a collaboration between the Tri-Counties made up of county workers. So I work for the County of Ventura. Our programs reduce energy use and help us all become more sustainable and energy efficient in our tri-counties. We have 3 services centered around 6 programs. That includes incentives, training, and technical assistance. Today's training is brought to you by Building Performance Training. If you're interested in learning more about our programs or signing up for more events, you can find us online at 3c-ren.org. And with that, I will pass things off to Mike and Jennifer for today's training.
Everybody, and welcome. Let's see. Do us a favor, and if you're up for it, in the chat, tell us what your background is. If you're an architect, or if you're new to construction, or new to the energy code, that really helps us. And I will take a look at the chat in just a moment here, and then kind of get a handle on where folks are from. If you're a licensed architect and need units towards AIA, we've got you covered. And today, Mike Horgan from Karn Collaborative, certified passive house designer, builder, a licensed contractor, is going to talk to us, give us the builder's perspective on heat pump water heaters. And I'm Jennifer Rennick. I'm a licensed architect, certified energy analyst, and I'll be jumping in here and there and adding to the content. So with that, I'm going to turn it over to Mike.
Hey, a couple of quick things. So are one of you admitting people? Because they keep popping up on the screen. So, okay, that's getting
Yep,
taken
I'm
care
admitting.
of. Okay. Second thing, apologize if it seems a little discombobulated. We had like hurricane tornado storms here in Morro Bay last night. So our office is knocked out, which meant all our Wi-Fi was knocked out, power's knocked out everywhere. So I just had to MacGyver a system to get into this meeting from my own house. So we're going to do the best we can with the things that we have available to us. So thanks for coming to these. We've got like 45 slides to get through, I think, and we've got about an hour to do it, and then we'll leave room for questions at the end. Jennifer's the real math building code expert. The idea of this is to give you the perspective of what it's like to be in the field and doing these, because architects and builders have very different responsibilities. We are an architect and builder firm, so we do both and speak both languages and do all of those things out of one office. And even in our own office, we have disconnects between how easy or how difficult it is to get things done. So we're going to go over some of the ideas related around heat pump water heaters, why I like them. We're kind of the overarching idea is that we're getting rid of fossil fuels. I think we're all in agreement. I hope we're all in agreement that that they are bad. Fossil fuels are bad. So we're doing our best to minimize them. We do lots of other things on our projects as well, but this is just related to our mechanical equipment today. So I think they're easy to install. Basic trades can be on the site. There are no special skills required to install heat pump water heaters. There's nothing too intimidating about them apart from doing it the first time. It's kind of like procrastinating. You spend 99% of the time worrying about something, then you take the 1% and do it and go, oh, that was actually pretty easy and didn't take very long. So that was our experience the first time, six years ago, I think we did the first one. Um, they're really energy efficient, and that's in terms of the source energy is going to the destination, and then ultimately lower greenhouse gas emissions. So, as the builder, I put together our estimates. I am still the estimator for our company. I've been an estimator for about 20 years. It's still the hardest part of the job. It's the hardest part of outside of being a psychotherapist when building custom residential homes, but the hardest part is still putting together estimates for projects. So, and it's because it's changing so fast. Like the world is just changing so fast, and especially this world of mechanical equipment is changing rapidly. And we'll talk about some of the kind of boots on the ground things that we see every day. But I like to make these pinwheel charts of what the costs are in some of our projects. And we often hear pushback about things. It's getting less and less now, but 15, 20 years ago, it's definitely like we can't build green, we can't build more efficient, it's more expensive. And that conversation is definitely changing now. You see a lot of American window companies making triple pane windows with great U factors. You're seeing lots of efficient equipment become available at lower costs. So I like to point out that just talking about the water heating system for a home, which is a fairly important aspect of living in a developed world in a home or in a multifamily unit. Uh, that little tiny slice of orange down there, that's the cost that we're talking about compared to total project cost. So all those other colors and little slices of pie are all the other things that go into a project. So in my opinion, the cost conversation is irrelevant. If you're taking it just line item by line item, it's irrelevant. It's kind of like you can buy a Patagonia jacket for $150 and it'll last you 2 years and then you can get it replaced for free. Or you can buy a different jacket for $20 and then you got to buy four more of those, five more of those throughout the course of the year. And you just have to keep doing that. It's a little tiny sliver that you're talking about, and it's a huge bang for your buck. So, okay. We've got a little format that we'll follow. So we'll describe some of the water heaters that are around, some that are available in our market. And then Andy from Imbalance, Jennifer's business partner, has developed a really cool flow chart that we're going to go through towards the end. So these are our typical available domestic hot water systems. Natural gas tank, electric resistance tanks. You've got your tankless on demands, tankless electrics, and you've got your electric heat pumps, and that's what we'll be talking about today. I've installed all of these throughout. A career is a weird word to say, but it's just throughout life. We are only installing heat pump water heaters nowadays, although we have used a tankless on-demand electric for situations like a guest house or an ADU on a property. That just
Right,
has
the code
it has a
allows
very
for that
small.
for
Yeah.
500 square feet or less.
So if
Yeah.
we're doing, say, a guest house, which we did on a project last year, that was it was a 400 square foot guest house. We used a small on-demand hot water heater just for the shower and the bathroom sink in that guest house. But we're largely installing just the heat pumps in our residential projects. So um, the kinds that are available, tanked and split systems. So these are just some of the brands. As a builder, and I'd like to think I can speak for a lot of builders. I think I represent builders, like builders probably more than policymakers, even though I know we all have to work together to achieve the goals that we are trying to achieve. These are the brands that are technically available. most builders like to find, I think most builders like to find that they try to find one thing, it works. They figure out how to install it. They figure out how to install it efficiently and not just maybe lose money, but actually maybe make a little bit of gross profit on that installation and then stick with that brand. So typically we're installing Reams and AO Smiths. We haven't done any Bradford White. We haven't done any Stiebel Eltrons. We haven't done any LGs. We have done a Sandon. Uh, but nowadays, we're largely sticking with the Reams and the A.O. Smiths because we know them, we find them dependable, and we find them readily available. And we have their phone numbers in our contact list. So,
Right. And then, Mike, just for fun, I was doing a little research this morning because I was like, oh, what other stuff is like Ferguson's Plumbing Supply and our other big box stores are offering. So now in our market, we've got Renai and Bosch, and we've got Navion is now making a unit that you could get at Ferguson's. And then I noticed we have someone on the call who's got the Ecologic split system. So that, that's great. So the market is opening up, in other words. So as they become more popular, we'll be able to get more variety in our area. But then, like Mike said, sometimes builders like to lock in on certain brands.
and that goes to something I said in the beginning of how quickly this whole world is changing. So just because we're using one thing and we have used one or two things for the last few years, well, we've used three things for the last 5 or 6 years. There's new stuff coming to market every day. I mean, it's a tech world now. It's not like we're going to the lumber supply store and looking at these things or to miners or Ace Hardware. It's a very tech driven world. So these things are changing and new things are coming to market. God, it seems like weekly a new sales rep is calling us. So yeah. So heat pump water heaters, they operate just like basically like a refrigerator. I think we used to have a slide in our workshops where we would surprise everybody who wasn't familiar with heat pumps and tell them like you're using them every single day. So our refrigerators are heat pumps. So they're taking, warm air, they're taking heat out of the air, moving it across refrigerant. So that compressor is pulling air across a coil of refrigerant, and that coil is being used to heat up the water that's inside a storage tank. So they're basic. We all use heat pumps every single day. Most of our cars are heated through heat pumps as well, but refrigerators are exactly what a heat pump is. So there's heat in everything, and we're just grabbing that heat through the use of the refrigerant and warming up water or warming up the air if you're using it for heating and air conditioning.
Just like your job site cooler, which this is a picture of the back of the pickup truck of one of my favorite Hearst Raiders. This is, yeah,
And bagpipe
same
player,
same
one of our
stuff,
favorite
same
our
stuff.
favorite bagpipe player as well.
Right. Yeah. So, like with all the architects and some of the builders on the call, sometimes it's just really useful to have something super common to be able to point to and just say, hey, like your refrigerator, like your cooler, the heat is removed from the air inside the cooler and it's transferred or rejected to the surrounding air. And just your heat pump water heater, heat's removed from the air inside the garage, and we move it or reject it into the water. And it's pretty much that simple.
And so these are the typical components of a heat pump water system. This is what we call an integrated heat pump water heater system. So they change, brand to brand, little things will be different. But generally, you've got a 30 amp 240 circuit dedicated, usually a double pole breaker in your panel. That's what we install on most of our projects anyway. You've got an integrated control panel on the face of the tank. Some of them are smartphone enabled. We have not had any of our clients try to run these systems from their phones, although I'm sure in the future that will be the only way to run them, or from the glasses that we'll all be wearing instead of using our phones in 5 years. But that's another. another topic. You've got a condensate line because there is moisture in the air that's being moved across the coils. So there is a condensate drip. It is just pure water. I'm going to turn the chat off because it's distracting me here. You've got your temperature pressure relief valve. Um, you have insulated lines, and there are a few little code niggles and wiggles about what lines need to be insulated and what lines don't need to be insulated, depending on the installation situation. You have electric resistance heating elements where there are different modes you can put these tanks in. So it is possible to run this in electric resistance as well, and not just a heat pump system. You've got an expansion tank and you've got your supply line. So that's the general makeup of these systems.
Okay, I'm going to jump in here on this one. So when we talk about, it's like, okay, the overall kind of concept of the whole presentation really is to kind of walk you all through a process that maybe as architects, designers, and the builders go through. So a lot of times, we say, okay, we know we need a heat pump water heater. That's kind of the way code's going, or it's our baseline, kind of baseline appliance now in a lot of projects. And so as architects, we're like, okay, fine, but I don't really know what size I need to help my clients figure out. And I'm not really sure how much space to allow for it. And then the builder gets out there and the builder's like, okay, so you got a heat pump water heater. Okay, great. I'm going to contact my plumber. And okay, maybe we got enough space. I don't know. That's the plumber still. They'll make it work. And so what we want to do is kind of up front give you folks some tools and things you can grab onto and some resources to kind of try and understand heat pump water heaters. And they operate a little differently than like the gas tank type, which would heat water very quickly, or your on-demand gas, which would heat a lot of water very quickly, continuously. So there is some sizing, things we want to review. And we have our, us architects, we're looking at, the first hour per the uniform plumbing code. Well, it's kind of interesting to me when you take a look at that, you look at your number of bedrooms, number of bathrooms, and you start to figure out what size tank you need. But when you go to your heat pump water heaters, even Energy Star gives you a minimum tank size that is slightly larger in certain situations than, 10 gallons larger than your first hour rated uniform building code. So I just want to point out that that's it's a minimum, right? So the tanks are a little bigger. So we're going to get into that, but I want to point that out. And then there's some other tips, like you could raise the set point on that tank if you need to 140 and do a thermostatic mixing valve. And then take a look at, this is just one brand, which is really common in our area. So I pulled this resource because we do see just a lot of reams being installed because they were one of the first to get out in our market. And they give you a sizing chart based on location and by 8-minute showers with a set point of 125 degrees. Well, okay, maybe your shower valve has a little less than 2 gallons per minute because you're meeting Cal Green, so it might be less. But an 8-minute shower in my household with a couple of teenagers and people in their young 20s, like we take multiple 8-minute showers back to back. So just keep that in mind when you use, the number of showers available in the sizing chart. And what that kind of comes back to is most folks will go to a bigger size on their heat pump water heater than they are used to thinking of on a standard gas storage water heater. So take kind of pulling that example all the way through. Let's say you're looking at that Ring ProTerra 30 amp unit. Then as architects, you're going to just go pull the actual spec sheets for the product and take a look at the first hour rating and get a match for what size, you need, asking yourself and asking your clients, do they take a lot of showers? Do they have teenagers? Do they need to fill a bathtub? And then you can reach out to the manufacturers as well to really help you size it. And then the dimensions, you'll notice that the tanks are taller than a standard tank, but they vary between, 63 and 75 inches tall for these units. And, the bigger one, the 80 gallons, even just over 24 inches in diameter. So start thinking like, how much closet size, how much room space do you really need? So with that, Mike and I are going to tag team back and forth on this stuff, but we're going to walk through like locating heat pump water heaters, because that's kind of the next, picture of like, well, what do I know? What do I need to know to locate it? And like the first thing is really asking your question about what climate zone you're in. Okay, Mike.
So when we sat down to start putting these things together, and Jennifer and Andy say to me, "What's the number one concern?" No thinking. What's top of your head? What's the number one concern with using heat pump water heaters? My answer is always space, uh, because I think we've gotten used to using tankless gas systems, which don't really require very much space, and now we're going back to a tank system, which does require space. So. Uh, from my perspective, when I know that we're going to be using an integrated system, the first thing we do is locate where it's going to be. We generally have a system that works for us and where we locate it for our projects, but that doesn't mean it's going to work for everybody. Um, there's not really any one single right way. There are definitely wrong ways, but not any one particular right way. So you can be creative, and we've definitely gotten creative on some of our projects. So um,
Right. And then when you're in, right, Mike, but like for a lot of the architects, they're designing in different places in California. And so one of the first things you have to ask is, does it freeze? I mean, that's like when I think of it as an energy consultant and architect, and I start looking at this, I'm like, okay, does it freeze in our area? Because if it does, then you have to locate it inside. That's just like you have to locate it inside. Or does the outdoor temperatures regularly below 40 or 45 degrees? That's kind of a cutoff for the operation. And then you can start to look in those other locations. If it's a semi-conditioned space or uninsulated closets are acceptable. And then Mike, right, as a builder, you go into like, okay, how do we want to fine tune it or tweak it or locate the unit when you're
yeah,
designing and when you're doing that work with the other architects, right?
and in a place like the Central Coast, which let's call the Central Coast Ventura to Monterey, even though some of us like to think of it just as San Luis Obispo. But I think it's Ventura to Monterey is what a lot of people call the Central Coast. So we've got a ton of microclimates. If we're designing a house in say San Luis Obispo, or we've got one in three in Morro Bay now, they're different than the ones in San Luis Obispo, and we have to design those and locate these mechanicals in different places than the one in Atascadero, which is really only a 20-25 minute drive away, but it's a totally different climate zone above the grade. I'm in a humid coastal cold climate here in Morro Bay, but it never really gets below 50, 55 degrees. Atascadero, it gets below freezing often in the wintertime. It also gets up to 105 degrees regularly in the summertime. So it's one of the cool things about living in an area like this is the challenge of designing projects differently that are only located 20 minutes from each other.
Right.
Uh,
Mike, I'm going to jump in again. Someone in the chat just mentioned, the cubic feet of airspace required for the units. Yes, that is coming up right after this. That's right on cue. So basically, climate matters because there's an operation range, a temperature range for these units, and the split system has a temperature range that goes to negative 26 degrees, and the upper range is like only 114. But, your integrated style, yeah, they cut off at around 40, 45 degrees, which means they go into electric resistance mode. And they'll even have an upper cutoff around 145 degrees. They go into electric resistance mode. So that's why climate matters. And then, like Mike was saying, how that whole system works, and this is like right on cue, that comment in the chat about access to air volume, is warm air is pulled across the evaporator coils, and that heat from the air is absorbed into the evaporator coils and it's transferred into the hot water. And so the more access to warm air the project has, the more efficient the appliance can operate. You want to
And it
add anything to that?
Yeah, it is about efficiency. It's not that say a Ream or an A.O. Smith, shuts off at 45 degrees. It still works and it will still give you hot water. It's just that it switches to electric resistance mode
That's
rather
right.
than heat pump mode. So you to my fear, being from New England and having been installing heat pumps for all of our projects, I don't know, since like 2007, 2008, I think. I often hear out in California, well, they don't work when it's cold. Ah, they're terrible when it gets cold. They're not. I mean, we install heat pump heating and air conditioning all over Massachusetts and Maine and Boston. I know there's a lot of questions coming up in the chat here, but we're gonna get to them. So let us get through stuff, and then we'll have time for questions at the end. So, um, but they still continue to work in the cold. In the case of the integrated heat pump water heaters, they're hybrids, so they switch to electric resistance. They'll still operate, just not quite as efficiently. So it's not that you don't have hot water, just in that time period, it'll be pulling your energy as electric resistance. So
Right. And then right on cue, then the chat. Oh God, I love this. So no wall insulation for a closet or laundry room. Is a laundry room location acceptable for slow? Well, yeah, that's right on cue. So this is that chart that Mike was talking about, that Andy and I created to kind of help you sort of bucket these different solutions. And it is kind of based on, like, related to that microclimate and the space you have allowed. So what we're going to do is kind of use this as a building tree and kind of work our way from left to right at the bottom. So, oh, Mike, should I just keep going? I'm on a roll here.
yeah, keep going. The questions
Okay.
are not waiting till the end, so just keep going.
Yeah.
Yeah.
Okay. So, you know, kind of the big picture thing, like Mike was saying, is, so do you have an attached garage and a large utility room? Okay. And let's say you're in a climate zone that doesn't freeze. It doesn't freeze in your garage, which is most of the areas of California we're talking about here with the Tri-County Regional Energy Network. It's different if you're up in Tahoe. You don't want to put it in an uninsulated garage or even a garage at all, probably. Okay. That's just not an option. But here, Central Coast, 3C REN territory, do you have a garage? Do you have a large utility room? Yes, great. Consider combining it with your laundry space because you'll have enough volume air. Okay, that's kind of like a no-brainer. And we're going to go through that. And then sort of that next question is, no, you don't really have those large spaces, but you could create something that's accessible from the outside. Okay, great. Like up in Atascadero, best performance combination there would be insulated closet with good doors and do a duct system. But let's say you're in San Luis Obispo and you're on the coast and you can protect it from weather. You don't have a lot of space. Never gets, rarely gets into those really cold temperatures. So you could do an uninsulated closet and do it with louvers. That's great. Then we go to kind of the next bucket and it's like, no, none of that works. And we're going to put it indoors. Makes the most sense. And then you got to ask yourself, is noise or cool air a concern? Because there is a compressor, there's a fan, and we talked about warm air coming into the unit, going across the coils, and then ejecting cool, dehumidified air into the space. And if that's a problem for you, then work with your clients located away from your bedrooms. Consider a solid door with ducts, so you don't feel the breeze on you. Or if none of those are really an issue, then you could do like a fully louvered large closet. And we're going to show you some pictures of each of those scenarios at the bottom.
And I think everybody will get copies of the slides afterwards.
Correct.
So what Andy did when she was trying to put these together was it's nothing's just plug and play. It's not like, okay, this is the one system that works for this one piece of mechanical equipment. There is a bit of thinking and common sense that has to be used. And you do have to know the people that you're going to be designing for. Do they have noise sensitivities? Then you need to locate it away from, say, a bedroom. Um, there are common sense things that you have to look at for each particular situation before you design where your location is going to be. So
Yeah, and then like take a look at this example here. This is I kind of added to it a little bit on the marketing, picture. Just don't forget your seismic strapping, and there's other good things. But the reason, like if you had a large space like this, and this is where you also did your laundry, then yeah, you would have your sink available. So you would be running your sink drainage, and you could take your condensate drainage and you could combine it. So it just makes it easy. Also, the waste heat from doing your drying and your laundering makes the room warm. The heat pump likes to be in a warm environment, and then it's going to eject dehumidified air, which kind of helps with the humidity regulation. So for spaces that have a large enough area, like the marketing brochure, that works really well. But we're going to talk about, some of the requirements and some of the things we're seeing on projects, just to give you a better idea of better ways of installing it and some troubles to avoid. That will kind of come at the end after we go through some of these examples. And Mike, this is a project that Mike installed, and yeah, you want to tell us a bit about it? This was a garage
um,
workshop for this client.
no, this is actually a house that we built in San Luis Obispo. So, and we were bringing people through the house. So just to give you an idea of size, I'm 6'1", 185 pounds, solid muscle only. But it gives you an idea how big these tanks are. So that's the kind of space that you need. I'm joking about the solid muscle. I don't think anybody got that, but
Okay, I laughed.
um,
I laughed.
yeah,
I know your sense of
yeah.
humor.
6'1" on a good day, 6'2" with my work boots on. Oh, cool. Ben McDonald's here. That's exciting. He's one of my favorite people. Um, so this is
Shout
an
out.
install that we did in San Luis Obispo, and it's just to show people that if we have the opportunity for a garage, then we are locating these in the garage. And if we don't have the opportunity for a garage, we'll show you where we're going to put them in other situations. So you've got your hot and cold flex lines up at the top. In this particular instance, we don't need any ducting because this is located in a garage. One advantage of this is an unconditioned garage, uninsulated garage, but the family does work on their bicycles in this garage all the time. So it is actually an air conditioned garage. So in the summertime in San Luis, even through the winter in San Luis, the garages get really, really warm. And this one is not as warm because that heat pump is taking the warm air and taking warm air into the system, taking the heat out of that system, and putting the cold air back into the garage. So they've actually got a really temperate garage that's kind of fun to work in, even with all the doors closed. So when you do it in the garage, it's a fairly straightforward installation. No big duct work is necessary. It's almost plug and play.
Right. And then
Uh,
Yeah, go ahead.
Yeah, these
Like,
are just
Joe.
two examples of as Jennifer's talking about, and one of the questions and comments was talking about the airspace that's needed. So we're just showing you two examples of what's good and what's bad. So you do have to make sure you've got some space. You need room around the unit for air to get to the ducts and for air to leave the ducts efficiently. So the one on the right is it's too close to a wall. I mean, you'd think that would be common sense, but it's not so common. So
Right. We are seeing folks carve out alcoves out of their garage to kind of get the heat pump like out of the way and just more and more. And so this was a picture on the, well, two pictures of job sites that I asked the folks working on it if they give me a couple pictures. And so they obliged, one on the left, big and open, no problem. One on the right, the designer, architect, the builder, somebody created an alcove thinking, oh, this will be a great place for the appliance. But that alcove is not wide enough. It doesn't meet the clearances. And so really, 24 inches, 12 inches, it's recommended as kind of best practices, but like even Ream literature, the installation manual says in there that you need that 6 inch minimum clearance when you install it like that. So the issue is that you have the potential for condensation. There you'll probably get condensation, but you'll have potential for mold-like substances in that situation, which we are seeing, and some folks asking their units to be taken out. And by that point, the homeowners, they don't really get what was going on. So one of the plumbers I know that I work with, like right now, he's been going around and he's like, I don't want to tell you this, but I've been going around taking out those heat pump water heaters and putting a gas on demand back in. And this is retrofit. So they already have gas. If this
and
is new, yeah, yeah,
we'll show you. See, the comments are always trying to stay ahead of us. So
yeah,
we will talk about split systems, and yes, a split system requires less room. Split systems are also, because it's my job to just be totally honest here, are also significantly more expensive than integrated systems. So you do need to be aware of that. And then it's two parts; it's a different system. So all of
right.
these things have their pluses and minuses. There's no right way, there's no one size fits all. There are wrong ways, so we're trying to help people avoid the wrong ways. So
Right. So, like architects, so my mantra to the architects is do that size, look at the sizing of the heat pump, go to the manufacturer. Most of them, they're trying to get the control panel and the exhaust port either on the side, a little closer, or on the top. But you have to understand what appliance you're going to use or hedge your bet. You don't know which appliance. You have to be able to access your control panel. The plumber has to be able to get in there to do work. So you really do need some clearance on the left. You don't need any clearance on what we would call the back, the way, the picture is oriented. And then you definitely need clearance on the exhaust port side, whether it's the top or the side. And so that makes your, quote unquote closet significantly bigger. So just kind of think about that. So you
and
set
real quick,
everyone up for success.
I'll make sure
Yeah.
I'm not I don't want anybody to think I'm opposed to any kinds of systems. Like we've done all of them, but it's our job here to be brand objective. So, and I think one of the good things about the work that In Balance and our Karen team do is that we are very brand objective, and we only want to do what's best for the client and the situation of the home. So we have used integrated and split systems, and again, they both have their advantages and also disadvantages depending on the situation. So we're walking you through the multitude of situations you might run into and trying to help you avoid some problems. So Jennifer will
Right.
keep walking you through this flow chart.
Right. So now let's show you some pictures of like insulated closet with ducts, and then we'll go on to some uninsulated closet with the louver doors, and all these installations were acceptable. And it depends on your situation, but we want to give you a variety. This is from a project that I worked on. And last night when we were reviewing the slides, Mike said, "Hey, how come this one doesn't have an inlet duct and only an exit air or exhaust air duct?" And it was like, well, this was from early on when we were first working with our mechanical engineers and designers to do heat pumps. And so this one, although it's an insulated closet, it's got the ducts. It had it had an undercut door, and they did some other things so that you would have air coming into the space. But now, we would recommend now that they do the ducted inlet and a ducted outlet. So I just want to point that out. And then there are lengths of, maximum duct lengths you need to work with. So for the engineers, designers, I want to point that out. And also at the time, it was like we did a lot of rigid ducting. And here's an example of another project we worked on. Now, a lot of our projects, the installation is going to flex duct, but, just to kind of point out the installation of this particular one, it looks like the duct on the right is kind of crimped a little bit. It's not really that bad actually in real life, because it goes out back and then curves around, but you don't want to crimp your ducts, but we are doing R6 to R8 insulated ducts. But this picture shows approximate depth on this was 42 inches, because we needed to make sure this 80-gallon tank had enough space for everything. But we knew it was extra generous. The closet's insulated. It has exterior doors on it. It's got a floor drain. The pipe insulation hasn't been added on here yet. But that's, gives you an idea of kind of the proximate width you need. And then the depth really, or doesn't have to be as deep as this, but they wanted to be able to have storage in and around it. Here's one of Mike's projects. So this is in a really mild climate on the coast, where it's okay to have an uninsulated closet with louver doors, and so no ducts needed.
And for architects, if you're in this situation, which Santa Barbara, Ventura, San Luis Obispo, Morro Bay, you have the opportunity to. We know we need this closet. We know we want to use this piece of mechanical equipment, so we're designing it in from the very beginning, and so we design it in as part of the design. And we hope that it looks cool. We want it to be beautiful. I know, like, we love to talk about mechanicals and passive house and fossil fuel free. You still have to have things that are pretty. Like, people still want to go to the house that they live in and enjoy looking at it. That drives all of it, probably first and foremost, and then the other things come in immediately afterwards. But so we try to design in enclosures and make them look like part of the house. Eventually, this closet turns the same color as everything else on the house. Is pretty freshly built in this photo right here. But so we build a lot of these louvered closets on the outside of homes and make it look integrated, like it's part of the home. So no
Right.
ductwork, lots of access to the air that you need. This is another one. So that previous picture was an 80-gallon tank. Going back to Jennifer's sizing of the systems, the 80-gallon tank was for 3 people, but they are 3 college students. It's a college rental for the next 5 years, and then a family will move into it. So we sized that one up because college kids take lots of showers and take super long showers and wicked hot showers. So this one in this photo is a smaller tank, also for a family of 3, but we know their lifestyle and we know that they're a pretty conservative family. and they're, a one shower a day family, and they're not taking long showers, and they're not taking extraordinarily hot showers. So we actually downsized the tank, and then our enclosure was a little bit smaller as well. This one's not quite done. We're putting a really pretty copper roof on top of that one that integrates into the design of the house as well. So, but again, an outdoor closet. So, yeah.
Yeah, mild climates, that works great. And so marching across our chart now, kind of that next sort of bucket here is, hey, we're going to need to have it indoors, outdoor, accessible to the outdoors, even if it's an insulated ducted system, accessible outdoors, not an option. So the next two pictures coming up, these are both projects that I worked on, where the one on the left, it's got the R6 ducts, which is now a new mandatory code measure, sealed penetrations, also a new mandatory code measure. It's got a solid door, it's ducted, it has your expansion tank, not all of the insulations on the plumbing, they were getting there, but that, you can do something like that. But again, give the architects, designers, builders kind of get an idea of the size you need, because you do need to be able to get those duct kits on the unit, and you need to be able to take care of the rest of the equipment. The one on the right, it also meets the new mandatory code requirements of net free ventilation area in the louvered closet door. So this space is a little smaller. You don't need the extra space for the ducts. But that louvered door allows the heat pump to communicate with the greater living space. And this opened up into a living area. And then, like Mike said, sometimes these types of systems don't really work anywhere. They don't fit anywhere. Maybe you're working on a large home that also, a couple situations. Actually, I'm just going to go to the next slide, and then Mike and I can talk about it, because this is showing the split system and a couple of examples here. But I've had projects where the home was really quite large. And so what we needed to do was have a quiet tank in the middle of the house, near the bathrooms, near the laundry room, where folks were really doing stuff. But we wanted that outdoor compressor unit outside, away from everybody, where it's quiet. And those, some clients have the money to do that. So that could be a great situation. Then I've also had really small projects where it's just the opposite, where the dwelling is really quite small, and there just wasn't any way to deal with any of the integrated tank type. And so we were able to use a small 43-gallon tank inside and the compressor outdoors, and it solved a lot of issues for that particular client. And the extra cost compared to the house was just worth it to them for the space. And Mike, I know you have something to add about this.
Yeah, I don't. I know that it seems like there are some people who are salespeople for split systems that are in this call. So I want to make sure we're not like, they're not taking this as a like, God, they're saying split systems are so expensive. If you were to look at the pie chart that we make for projects, an integrated system is like 0.2% total project cost, whereas a split system is like 0.4% of a total project cost. So it's just that item for item, one is more expensive than the other, and where it's our responsibility to let people know. If you're building a home, they're not like, that shouldn't be the make or break item on your home design or in your construction budget, but it is just something to consider about. One can be twice as expensive as the other, but they're still fairly small numbers when looking at the total construction budget of a project. So,
right. And then, Mike, and so like I do a lot of work for multifamily projects. And so we install a lot of split systems in the multifamily projects, because you can gang up a number of the outdoor units, right? But we're talking single family today, single family design. And so you can gang up a bunch of the outdoor compressors. They can all feed into the tanks. And then from there, it can go to a swing tank. And like that whole system is space savings worth it. It's a central system. And then we've done, multifamily where they have the space where everybody gets their own individual heat pump unit. It just really depends on the climate and the parameters of the project.
Mhm.
Mike, this is one of your projects.
Yeah, this is a project we built, I can't remember, a couple years ago. It's just to give you, again, you're going to get copies of the slides. So it's just to give you an idea of what the plumbing prep for, this is for a Senko split system might look like. I was just thinking it was interesting because Jennifer was saying, try to locate, if you can, locate these near your laundry area. When we're designing, we're trying to keep our wet walls in close proximity to each other. And some of the ADUs that we design, we'll design a 3-bedroom house that will have just one wet wall in the entire house. So we are trying to keep things close, but there are different situations. There are, affordable ADUs that are designed to be built quickly, and they're not super custom and not super pretty. There are single family residential custom homes where people have accoutrements that they must have in their projects. And then there are multifamily projects where developers are building them, and the budget's going to get shaved and shaved and shaved and shaved and shaved. Our our heat pump water heaters don't necessarily go near the laundry room. They're often going next to the custom stainless steel dog wash that's being put in the garage. But we're still trying to locate them in situations where other plumbing is going to be put. This one here, that's a laundry room where we were locating the Senko tank, and in the end, the washer and dryer were also right next to that tank system. So we kept most of it all in one room. It's a good way to think if you're trying to keep things efficient.
Right. And then wasn't there like a dog wash, and then there was the guest bathroom just right there as well. It
Yeah,
was like all
yeah.
close, which saves on plumbing costs as well and
Mhm.
energy. And it makes that tank, the volume of tank of water last longer if you're not loading up large plumbing lines with your hot water to get far across the house. So we do preface that, try and get your tank as close to where you are going to use the hot water kind of first. And then you got to look at the overall design to really understand whether it makes sense to, locate the unit, no matter which type, completely indoors or completely outdoors. Now, real quick as a sidebar, and I say quick because we're in the builder's perspective. We're in the kind of that part of the training, not really specific code, but you should know that under the 2025 Energy Code, given installations of some of the heat pumps that were not done so well, a lot of the research pointed to needing some kind of regulation that folks could point to or look at that said, hey, you need to make sure there's a certain amount of volume of air associated with these integrated heat pumps. And the manufacturer spells it out really well. Every manufacturer's installation manual I've gone to seems to spell it out really well. But what a lot of us found doing the research is not everyone reads those things. And it was really hard to, as a building inspector, or maybe your HERS or ECC rater out there looking at all pipes, plumbed, et cetera. Folks weren't really following it. So I put this in here for you guys to have as a reference. But the way the code kind of looks at it is, are you following the manufacturer's method? If you can prove that you are, you're fine. But let's say you're doing a ductless installation, well, then you need some minimum amount of cubic airspace, which is based on the compressor size of the unit, or you need a minimum amount of net free area. that can communicate with the larger space, also meeting the required amount of volume. So I put these excerpts in here for you to have a copy of, to look at. And then if you're doing a system like that that is ductless and you're looking at, well, is it appropriate to locate the tank outdoors? Architects, I want to point out that on your Title 24, so Energy Code Part 6, CF1R, there is a call out for this. And I apologize, let's see, now I got to click it. There it goes, yellow highlights. There's some required special features that you should pay attention to. That's usually on the first or second page. And in this case, a NEA rated heat pump's required. So it's going to meet a certain energy efficiency. And a heat pump was picked out for this particular project ahead of time. And so you go into the report and you're going to go to the water heating system and water heater heat pump section. And it's brand specific. You can change the brand and field, but this is where the builder, architect, you need to coordinate, because really these are supposed to be brand specific or at least meet the efficiencies. And then there is an option to show in your report that the tank is located outside and that the air that it's communicating with is maybe ducted or louvered in this case, but communicating with the outdoors. And so if you're in a climate zone that's mild, like this one, San Luis Obispo, this report was run with all those things being outdoors, might take a little bit of a penalty, but there's enough other energy savings measures that it balance out and the whole project complies. You know, for other projects, you might see that the tank is indoors within an insulated part of the thermal envelope, but there's a duct system going to the outdoors. So this is important for you to look at as architects and to coordinate with your energy consultant and your intention design and see how it performs. And this, it's useful to take a look at that. And then I'm going to give you the code requirement to say, hey, if you do a system design that is ducted, then there's some requirements now about the ducts themselves. And I'm going to also direct you to some other courses that we teach with 3C Ren that will specifically kind of walk you through where you find these mandatory measures in the energy code. And, spoiler alert, it's not in the residential section of the code. It's actually in the overall arching, section 110.3C7. Okay. But you can also talk to me as a code coach and I can help you with that. Okay, Mike, real quick. We're
Yeah, I'm
gonna
gonna wrap. We got
run
about
through
10
some basic
slides.
stuff. Yeah.
Yeah, 10 slides. I'm gonna go through them real quickly. So care and maintenance, these systems do have filters. You do need to be able to access the filters. We'll show you a couple instances where you can and can't. So you don't make the same mistakes that other people have. You want to always be able to access the control panel. Someone in the chat asked about, could that tank be facing a different direction? So the duct wasn't facing the wall. Sure, but then you wouldn't be able to access the control panel, which you do need to be able to access from the front so that you can operate the machine. So yeah, you could turn the tank a different direction and the duct won't be facing the wall, but you also won't be able to turn the machine on. So losing battle on that one. There are different modes. So there's the efficiency mode, which is only heat pump. Now they are hybrids, so they can use heat pump and electric resistance. They can operate in only electric resistance, or you can put it in vacation mode where it stays a stable 60 degrees and no one's in the house, but the water is not cold, but it's ready to be turned on. This is an example of accessibility to the filters. They're on the top of these integrated machines. The one on the left is one of our projects where you are able to access the filter. The one on the right is not one of our projects and you are not able to access the filter. So that system can be finagled. You can move that flexible line there and adjust it and get that filter out eventually on the right. But just little things to think about. So as your plumber is putting in the lines or you're helping your plumber put in the lines, make sure that they're using 90-degree elbows to get the pipes out of the way so that the filter can be picked up and cleaned real quick.
And your electrician, as a builder, to make sure the electrician doesn't take your electrical conduit to just straight over your filter. And some brands now are having the filters, they've kind of thought about that, and they're creating some units where the filters come out from the side to help alleviate it. But yeah, most filters are coming up over the top.
Mm-hmm. Floor drains and drain pans. So Jennifer and I had a discussion last night that there are different instances where some of these things are required. So if we are putting, if we're designing and we have a garage in the project that is not above living space, we don't put a drain pan in our systems, and we generally locate the tanks. If we're using an integrated system, we'll locate the tank next to an exterior wall, and our condensate line will just drip out that exterior wall, usually into a mulch bed or a garden of some type. So if you don't have access to that, you can run yours into a drain pan and a drain line that would be in the floor near where your tank would be located.
Right. And then we, one of the diagrams early on and some of the marketing material, a lot of times you'll see it kind of disappear into a wall, or like in that garage workshop installation that Mike, had, where it goes into a wall. Then what you don't see is that sometimes what it goes into is the same like waistline that your washing machine, sends water out to your system, or it could go into like the utility sink that's near there. But you just have to think about it, think about your
Yeah,
strategy. And
we've done all of them, and all of them work. Yeah.
yeah, yeah, like Mike was saying, a lot of times you kick the condensate line out away from the building and give it to the landscape, which is fine because it's just the same type of condensated water that you get on the outside of your cold beverage. It's just water from the air. So it's not an issue with the water having any problem to be sent to your garden or the outdoors. But, every once in a while, there'll be some miscommunication on that. Like one of the projects I worked on, we went out just to take a look at the whole. We were out there for commissioning of the heating and cooling system, and not specifically for the water heating. But when I was there, I noticed that, okay, this unit had a condensate drain line that just went nowhere. And so they had to come back and fix that. But that happens. So I suggest the architects, they clearly delineate like a floor drain call out and really make sure it's there. If you're doing like like in this case and that other project, these were on the second story of a project, and make sure that's addressed. The other kind of recommendation for best practices is that all the hot and cold pipe plumbing be insulated. And in the multifamily code now, you have to have 5 feet of hot and cold. In the single family, it's not really called out as a specific on the cold, but the manufacturers, almost every one of them, recommend that you insulate the first 5 feet of that cold water piping anyway. And then you can get credit in the energy code if you do call out all pipes insulated. And sometimes that is a super helpful credit. And then if you do that, then you would have a HERS or ECC, now as it's called, rater, come out and verify that you met all those plumbing requirements. And it does include like cutting and taping and sealing the joints so they go, all around the pipe. And this was, I got this picture just before he finished up the job. So then he'd come back and he started taping all the joints on that. And then this is an example that I got from one of the HERS people I work with. So it's got good stuff in there like the expansion tank, and it's got the pressure, temperature, condensate drain lines going out, and they used a flex line for hot and cold to kind of isolate some of the vibration that these units can have, so that didn't translate into the structure. So that part all seemed pretty good. But then the installer, the plumber, totally wimped out on getting the piping insulated, because the flex piping is notoriously hard to insulate. So, um, you know, it's recommended that you still get that first 5 feet of hot and cold pipe insulated, even if you have to figure out a method for doing it. Let's see, just another example for you guys for what it could look like to have a closet situation with a solid door, clean closet, but it gives you an idea of the space. R6 ducts, pipe insulated. This way it gives you access. Tanks, they're warranted around 10 years. So when you think of how long your house is going to last or how long that dwelling unit's going to last, it lasts a lot longer than 10 years. So it really behooves kind of, I think, all of us to be able to easily come in and do maintenance and replace these. And by maintenance, make it easy to get to the filter and make it easy to get to the control panel and make it easy to check on the rest of your equipment in there, which means a little more space than maybe you're used to thinking of. And just FYI, again, just to point out that the manufacturers themselves are saying, hey, here's what you need to do if you want to deal with one of these units in a closet. And so like this example from Ream, they do show the exit exhaust port facing towards the louvers in the door at the same height, meeting the net-free ventilation area requirement. And then the closet needs to be sufficiently wide enough that you can put your hand off to the left side for this unit and look and, read the control panel. So that kind of goes back to that question in the chat about, can you rotate it? Yeah, and in fact, you should rotate it, but just now you need to have enough space on that left-hand side so that you can read and, make the appliance useful. So some brands are starting to put the exit exhaust port at the top of the tank to kind of alleviate some of these issues. And Mike, anything you want to add on that, on those last pictures? And then, of course, please tell us what you really look for on projects.
Not anything so much in the last pictures. I mean, you've got to be able to access the control panel. That's like your phone in your hand. Like if you can't access that, you can't operate the system, and you want to make sure the ducts have space. Like again, space is the first thing that comes to mind when we're talking about designing these into our projects. So, and then as a builder, and maybe not someone who is always doing this in our projects and always pushing the envelope with these things, but if someone's telling me by code that I have to do this, I'm looking for price. I find the integrated systems don't vary too much. And again, there's a significant difference between an integrated and a split. Line item, there's a difference, but overall total project cost, they're still both small expenses compared to the cost of a total project. You're going to be required to have hot water in your house. So you're going to pay a few $1,000s or a little more to get that. I'm looking at the warranty of the products. A real big thing I'm looking at nowadays is the availability of the product and what we can get. I don't want to sound like I'm going off on a tangent, but we're seeing a lot of our old Central Coast supply houses. A lot of these companies are being bought by large private equity firms and being consolidated. And all of a sudden, the access that we had to equipment a month ago is no longer available at the place we used to get it, or that place has suddenly gone out of business and they've closed because that's, branches get closed really quickly. So we see a lot of San Luis Obispo branches get closed and then they move the branch to Santa Maria or Paso Robles or down to Ventura, and we've lost our access to our reliable plumbing house. Which that's an actual thing that's happened. We're seeing it with our roofing companies as well, are being bought by large private equity firms, and we don't have access to the materials that we used to even a year ago. So availability of the salesperson who I'm going to talk to, and as a builder, I need to know that when I'm talking to them and they say we can get that for you and we can have it here next week, that I believe them. So that's why a lot of builders tend to find one thing and stick with it. They trust the person on the other end of the phone. Um, Dimensions, again, that's your space, and looking at where you can put it, your ducting requirements. Do you need to? If you do, are you near exterior walls? Do you have access to air? Uh, all of the things we've talked about, we're putting 5 to 10 years worth of experience in a 1 hour slideshow. Um, but those are generally the things. They're not that hard. I was intimidated the first time we did one. I was really intimidated doing a Sanko the first time because it was this new fancy thing. And then we got it and did it and thought, oh, yeah, we're just gluing PEX pipe together like we do on every other project. Okay, this isn't that hard. So, um, yeah, I don't know. They're not that hard.
That's right. Oh, and I noticed a couple things came through the chat. One I do want to address. Ruben asked the question: can the split system tank be placed outside and slow? Like, here's the thing with the split system. The idea is that when the system is split, you can now keep this tank of water warm. There's no moving parts, there's no noise, there's no sound. It can be installed in like that one shot that from Mike's job where it was installed in that laundry room. They actually put it in a cabinet. It was built in it because the tank, you could get a tank that's like maybe 20 inches in diameter, depending on which of their tanks you choose from, and the brand, and then it could just be in a cabinet, and so it's really a small space. The whole idea is to keep the tank of water really warm. So personally, I wouldn't buy that system and then put the tank outside, no matter what climate zone. I'd put it inside in the conditioned envelope, keep it warm, keep it a nice temperature. Takes very little space. The situations where we're showing the heat pump integrated style outside, it's an appliance. You're doing the performance method on that to understand the pros and cons, like the trade-offs of putting it all outside. But like Mike and I said, like once you move to the North County of San Luis Obispo, or some of the climates that get a little colder, I mean, I still, if it's not inside, because maybe I don't want the noise and all that. I mean, we talk about an exterior closet, but the closet itself, I would do an insulated closet with really good weatherized doors, and then I would duct it. So that way the tank itself and the space around the tank all stays warm. And then the compressor, condenser, heat pump unit on the top, it can communicate through ducts to the outside because the temperature is mild. Or like Mike said, it's not that it doesn't work when it's colder. If you're not in a freezing climate, right? Because that's a different strategy, then it absolutely needs to go like in a basement or inside your house. But if you're in a non-freezing area and it's colder, I would do the insulated closet and just keep the tank warm. So I hope
I'm
that
gonna.
helps.
I'll say one last thing as I'm taking my consultant hat off and my tree hugger hat off and just putting on my, hey, I run a construction company as well, and we have big overhead and a big payroll. And I always say to our team, the two worst things that we can have, the two most expensive things that we can have, not mistakes, like we make mistakes every day, all day, like 100 every 10 minutes and we just fix them instantly. That's what a construction crew does, and you avoid mistakes. But the two most expensive things we can have are injuries and callbacks. And I'm proud that we have never had a workers' comp claim, but we also have never had a callback on any heat pump hot water systems that we've installed. So I actually didn't really think about that until just now. We have never had a callback for one of these systems, which is kind of remarkable. So if someone says, well, I don't know if they work, I'm happy to talk to them and say they do. Actually, it's one of the few things I don't worry about. So uh, they've been running successfully on all of our projects and are right now. So yeah.
Yeah, good point. And then, if you have questions, I forgot to mention this. I didn't click the slide. Code Coach. I mean, we are code coaches to you guys. And I do see another comment in the chat. Robert says, Andy, my business partner, she, in other presentations, yes, we have spoken about her system. It is a harvest thermal system. It's a little different. It's a combination of providing space, heating, and hot water. And so that's kind of like a whole nother sort of bucket of heat pump technology that can do both. And so what it is she has a large tank. She does have a sand and outdoor unit that creates the heat and that makes the warm water, the very hot water, actually 160 degrees about, in this oversized tank that's super insulated, because that hot water not only can be used for her domestic showers or whatever, but that hot water goes into a fan coil unit that then blows warm air and heats her house as well. And so that's that's engineered to do that, which is different than just the integrated only heat your hot water or use the sand in as a separate system, only heat your hot water for
And that
domestic
harvest
uses.
that harvest system deserves its own AIA lunch and learn, more so than like a 3C Ren objective class about heat pumps. But if you reach out to Harvest, they will be more than happy to talk to you at length about how their system works. But there are constraints and advantages and disadvantages of that system as well. So all of these have to be looked at, kind of the individual design and the individual installation situation and what's available and what's not. So.
Right. And then the whole market now for is really shifting. It's shifting quickly. And then partly because in other places like in Europe and Japan and parts of China, I mean, for a long time now, you could get like Altherma or like Monoblock, or there's a bunch of other brands out there where you could have a heat pump system that heated your hot water and could heat your space. And the thing is and then some of them were designed so that they could switch back and forth to heat your hot water and provide space cooling. But like Andy's system is only space heating because it just does water heating. And like I said, we could talk to you so much more about all these, including we'd love to talk to you more in April for the builder's perspective on insulation and air sealing, which is coming up. And I'm looking at the time and I'm thinking, I better hand this back over to Chloe to talk a little bit about this. But then we still have a few minutes and we're totally happy to stay on and answer questions. And I'll look in the chat and see if anything else is coming through.
Thank you so much, Jennifer. Thanks, Mike. Yeah, we still have plenty of time for questions, like 10 more minutes on our schedule for today. And yeah, thanks, Jennifer, for mentioning it. We do have another course coming up for Builder's Perspective April 1st. So if you liked this, we'll be back then for more. And we also have a few other courses coming up. Jennifer, do you mind going to the next slide?
Oh, yeah,
Right.
sorry. I was looking at
Or will we be there on April 1st? Or is it just a joke?
I know
Who
Mike, I
knows?
really wanted to put in like an
Oh
April
God,
1st pun there, and I couldn't think of anything good. I was like, no one's gonna get this. So thank you.
I would have.
Yeah, no tricks, only air sealing and insulation. Um, okay, so hopefully you guys have seen a survey pop up on your screen. It looks like a lot of you guys have already taken it. If you haven't, it really does help us out if you give us your feedback, especially at the bottom where it says, what other event topics would you like to see 3C Rent offer? If you guys tell us what you want to see, we can almost always make it happen. And it really does help us decide what we're going to offer in the future too. Um, as I mentioned at the beginning, we're going to be having the slides and recording from today's talk sent to you in the next few days. So if you don't get it right away, don't panic. By next week, you'll definitely have it. We've also got a few upcoming courses that you guys might all be interested in, including in mid-March, we've got an Ask the Experts class with Judy Rachel on load calculations. This is a newer thing that we're offering. So instead of kind of a planned lecture, it's just a Q&A, kind of like an office hour style dialogue with some of our instructors to ask specific questions, maybe really detailed projects people are working on. They've got a really specific question about. You can bring those to these kinds of events. We've got a whole bunch offered throughout the year. The first one we've got is on load calculations. So if you guys are interested in that, definitely check it out. And you can also keep your eye on our emails. We're going to have more information about the rest of the Ask the Experts topics for the rest of the year coming out soon. And if you have any questions, of course, you can contact me. And I'll pass it back to Jennifer and Mike to finish answering questions for the next 10 minutes or so. Thanks.
okay,
I see. I see one question from Ruben, and I think that's
yeah,
Ruben and Ventura, who I think we know, um, about the HRV system. And I'm looking at that question and thinking I could come up with an answer. But one of the things I often say on our job sites is, I'll get asked a question like, how do we do this? How are we going to do that? And I'll look at it and go, well, I don't know how to solve that problem because I haven't solved that problem ever before. So. Uh, I've never thought about where an HRV system goes in relation to a split system. There are so many different types of HRV systems which have different installations and um, requirements for the different types of systems. You know, we've got ducted systems and we've got ductless HRV systems, and we do both of those. Um, I haven't really thought about the proximity to a split system before, so I don't have an answer for that. I don't know.
oh yeah. When I saw that, I was looking at that, going, "Oh, do you mean split system as in our split? Are we talking hot water, or did you mean split system in space conditioning?" And then my first instinct was, "Oh, we had mentioned putting your heat pump system for heating hot water, maybe combining it with your laundry space if you have a really big space, or if you have split heat pump water heating, like the picture Mike showed, where the tank is in there with your laundry room." Then the thing with the HRV, ERV is some of them explicitly say, don't put these in your depending on the brand, depending on how it's ducted, depending on what you're doing, they're saying, no, don't put exhaust in your laundry because of humidity. Like put it in the hallway outside the laundry, or if you have like a Panasonic unit that's all integrated as one, it'll say, no, don't locate this in your shower room, your bathroom, your laundry. You want to locate that unit like in the hallway or just down from that. And then if you have, really fancy ERV, HRV systems like the Zender and some others, then you've got these 3-inch distributed ducts throughout the whole house. Depends on the size of the house. It's probably not an issue. So it's kind of a longer way of saying what Mike said, but it's nuanced and it depends on which equipment and what you're picking.
Yeah, and then that goes to another question in the chat from Ruben of would first choice be an outdoor closet rather than taking interior space up? It's not really a first choice or second choice. It's a looking at the whole macro picture and saying, well, what fits this particular project, this particular design, this particular building? Is it custom res? Is it a multifamily? Is it commercial? Do I have a garage? Do I not have a garage? Do I have outdoor space? Do I not have outdoor space? Could I make the outdoor closet a feature of the landscaping? So there is no like yes or no situation. You'd have to look at the whole project and see what's there, what's being designed, what kind of spaces are being designed, and you've got options. That's a good thing.
Yeah.
Yeah.
And being an energy consultant, I go back to, well, what climate zone are you in? Okay. Like, are you in a really cold area where it just doesn't make sense? Like, even, oh gosh, one of the uh, energy consultants and folks I work with, they were saying, hey, it seems counterintuitive, but in certain places in our county, like out in Lompoc, they're like, it doesn't freeze, but like all winter when it's socked in with fog and it's just cold. I mean, if you put the appliance outdoors in an uninsulated closet, it just probably will operate a lot of hours during the whole winter, back and forth between electric resistance, going to the heat pump, electric resistance, kind of trying to keep this thing warm. Like, I'd probably do an insulated closet again with ducts in that area, and I for sure wouldn't Tascadero, but it's perfect. Seems fine, like climate zone 6 along Santa Barbara and climate zone 7, and our mild
You
areas,
do
climate zone 5. So,
you do really have to pay attention to those climate zones, though. I mean, it's one of the awesome, beautiful things about California is the wild microclimates. I mean, you can surf in the morning and snowboard at night, and maybe make it back for a surf in the evening again. But we do work in slow where it's super temperate, and then I drive home from St. Louis to Morro Bay, and the temperature drops 20, 25 degrees every night. We're doing a lot of work in Altadena, which is basically, LA, the fire rebuild stuff. And you'd think, well, it's going to be really hot. And it is really hot. But it also snows in Altadena in the winter. And it's right at the foothills. It's right at the bottom of the foothills. So it gets really cold there in the wintertime. And it's in the 30s and in the 20s in the winter in a place like Altadena. So it's LA and you can see LA, and it might be 100 degrees as you're driving through LA. Well, maybe it's 60 degrees as you're driving through LA, and it's going to be 30 degrees in Altadena, which is 20 minutes away. So it's a it's a nuanced thing. It's kind of cool though. I mean, it makes every project interesting and another challenge.
right. We ran some calcs for Mike. He doesn't know this, that I played around with one of his projects models. But I did, because I was like, I wonder, because I played around with how sensitive is the software to kind of predict that. And it's like, yeah, for a climate like that, that's both hot and cold. If assuming you do things to make sure the system doesn't freeze, and like you get all the plumbing lines inside the house, like, and then deal with all the plumbing and whatever and access to it. Like, it might be a different way of thinking about it. So like you have to have freeze protection, but then just in terms of like, oh, does it communicate with the outdoors or not? Is the tank communicating with the outdoor temperatures or not? It's like climates like that. It's like, oh, we get a boost in the summer because it's really warm outside. So that, your tank's staying really warm. And then in the winter, we get a hit on the performance calcs, but there's other stuff in there that makes up for it. So overall, the house passes. But is it like the optimized solution for that system? It's really climate driven. Yeah.
Cool.
And let's see, scan the chat. Did we miss kind of anything?
I think we got everything. It's
Um,
10:59. Great job,
okay. Well,
everybody.
I guess we did. Hey, if we missed anything, reach out to us for the code coach. And if you need to get a hold of us for anything, you can totally get through to us through Chloe, um, code
Yeah, someone
coach.
asked someone asked for our emails, which Chloe, you can give them out if people reach out to you. But I think we're both probably pretty pressed to answer individual emails.
Yeah.
We used to do
Yeah.
that a lot, and then we'd get this influx of 25 emails with questions, and you think like, oh,
Yeah,
that's going to take me
absolutely.
6 hours to answer.
If you guys have questions, reach out to Code Coach or reach out to myself and I can get you answers. But I think we're gonna, yeah, save Mike and Jennifer the email influx. And the survey is a great way to get us to answer some of your questions too. So if you guys want them back for a specific topic, let us know. And yeah,
You
with
can
that,
stalk us online.
yeah,
You can find us.
that
Yeah,
as well. That
that's
as well.
true. I mean, you can find us, but yeah. But I tell everyone go through the Code Coach because also that helps us understand and keep track of how we're doing, how 3C Ren is doing, and how the programs are impacting. So we do want it to come through Code Coach.
Yeah, absolutely. Well, I think we can wrap things up here. Thanks so much again to Mike and Jennifer, and thanks everyone for joining us today. Hope to see you
Yeah.
guys at another training soon.
Thanks for
And
coming,
thank
everyone.
you. That's right.
See you
Thank you.
soon. Bye.